Hello, and welcome to the United States National Herbarium. Established in 1848, when 50,000 specimens were accessioned from the United States exploring expedition, it today spans 3 floors here at the Smithsonian National Museum of Natural History. Home to about 5 million specimens, it is currently among the world's largest herbaria. The United States National Herbarium encompasses all major land plant lineages, as well as algae and lichens. Our collections of composites, grasses, and several other flowering plant families have all benefited greatly from a long history of research and study and are particularly significant. The same can be said for most of our cryptogamic collections. Although our holdings span the globe, our strengths lie here in North America, the Neotropics, Pacific Islands, and the Philippines. The herbarium is especially rich in type specimens, which are exceedingly important and number well over 100,000. The United States National Herbarium is home to packeted and liquid preserved material, various bulky specimens, and an extensive collection of woods, as well as a significant number of pollen and anatomical microslides. However, pressed and mounted specimens such as these account for the vast majority of our collection. Traditionally, access to this incredible resource has been, and continues to be, through research visits and specimen loans. However, our staff have long recognized the importance of making these collections and their data more broadly available. Digitization efforts here at the National Museum of Natural History began in 1963, with the first digitization project in 1968 focusing on our type specimens. Over time, non-type specimen data and eventually images were incorporated. This was a tedious process, but in 2012, our database had included 1 million specimen records. At that time, we were unable to digitize much more than the incoming material, but in 2015, everything changed.
Before 2015, we were attempting to digitize our collection in various ways through crowdsourcing and through optical character recognition, that's OCR. And although they made digitization a little bit faster, they weren't ramping up quite to the level at which we needed to digitize the whole collection, as that was our goal for the next 10 years, was to get the herbarium completely digitized. At that point, the Smithsonian's digitization program office came to us and asked if we would like to use a conveyor belt to digitize our collection. And of course, we said, yes, we would love to do something like that. And that just changed entirely how we were digitizing the herbarium. And so instead of being able to digitize maybe 1 case per week, instead, we were then able to digitize 3 to 4 cases every single day using the digitization conveyor belt. In order to do that, we first have to prep the collection to make sure that the process is efficient as possible. And in order to do that as well, we needed to make sure that our collection was extremely well curated, which we did. And so before the conveyor would even look at the specimens, we had to go through each and every case and make sure that they were properly curated. And then second of all, we needed to barcode the folders. And the reason that we would barcode the folders is because we were taking the taxonomic names off of the folders and not off of the specimens. And that was by clumping that data into one place, we were able to make the process much more efficient. So what we had done, we would put dummy barcodes onto the folders. And so we would put a blue dummy barcode for the genus, and then a yellow dummy barcode for the species name. And then the conveyor process would first transcribe these folders, attach the name back to the barcode, and then when the specimens themselves were run through the conveyor belt, in the metadata, the barcode for the folders was implanted into the metadata for the specimen. And therefore, the specimens would always be carrying the taxonomic name barcodes with them. And later on, these would be, the names would be reattached to the data when they when the data would go into the data catalog. Welcome to the conveyor room. This is where all the magic happens.
So I am taking specimens from the herbarium collection and placing them onto the conveyor in an organized fashion where they'll run down the belt until they reach our camera. But to give you a little bit of background of how we go about doing this process for the workflow, I'm just about to finish up this group of specimens, and I will start a new folder. So I will give you a little bit of an explanation whenever I get to there. So we start with one folder, and we will remove the contents from the folder. We'll then place it onto the belt, and then start digitizing all of the specimens inside. We've done a small preparation step before we have done the run of the conveyor today, where we've added the barcodes to all of these specimens first. So you might have a few questions about how these specimens are processed in on our conveyor. So stop. You'll see that at the beginning of each day, we start our imaging process with a couple of targets. So we have here a color checker target from X-Rite and a Don Williams target that we will capture just at the beginning of the day to calibrate the camera. We use a 100 megapixel camera that shoots at 540 ppi. And we do that so the images themselves can be usable for a number of years. They are of archival standard. They use guidelines similar to those created by the Library of Congress, which created the federal agency guidelines for imaging. And we will send those images through to a next step process where we deliver them to a transcription team that will then extract all of the data from each label, and it will deliver that back to our servers, which are then ingested into the dams here at the Smithsonian. So this conveyor has been used to digitize over 16 million specimens on 3 continents. And it's we're approaching 3.5 million specimens here in the Smithsonian collection. So you might notice that there are black squares that have been painted onto the conveyor track. These are used to help our camera recognize where specimens are located. So we actually take a photograph that is larger than the specimen itself, and then we crop away the extra black space around that specimen. There are also holes on the conveyor that you'll see on the gray parts across the conveyor. Those are used for sensors that are down by the end of the conveyor. There's one underneath the camera, and then there's 3 down by where they are removed from the conveyor. That allows us to place the specimens on the belt, and that's how the camera recognizes there is actually an object there. The barcodes, at the same time when we are taking the photograph of the specimen, those are being read out by our software, Pixel, and that is being ingested into a CSV document that's created while we're imaging. Afterwards, that goes into our transcription workflow, and that's how we connect all of the different pieces of data.
The mass digitization process does not stop in the conveyor room. At the end of each day, the conveyor images are batched and sent in several directions. The specimen images are imported into the Smithsonian Digital Asset Management System through an automated vendor file copy utility. They are permanently stored in this repository. From the dams, the images are imported as multimedia records into EMU, Botany's catalog system. Additionally, Both images of the specimens and images of the folders are sent to Alembo, a transcription company subcontracted by Picturae. The label information and the taxonomic names from the folders are combined into data sets of 3,000 to 4,000 records, which are sent to Botany for review. Once reviewed, the data records are imported to EMU in batches of 20,000 to 30,000 records and connected to their specimen images to create a complete data records for our Botany catalog. By having images and data sets batched in large quantities, we are able to create 40,000 to 50,000 new catalog records every month with a high-resolution image available for all researchers worldwide. You can find our records in our own online data catalog or through data aggregators such as GBIF and iDigBio. In October of this year, we will have been working at this project for 6 years. Right now, we have 3.3 million specimens imaged. And we hope by the end of the project, probably in January of 2022, we will have 4 million images of our herbarium. And that means that we have digitized thousands of herbarium cases, and we have added tens of thousands of new taxonomic names to our catalog. And most importantly, we have added an innumerable number of specimen catalog data to our catalog, and it's available to the world. We are very proud of this project, and we really hope that this makes a difference to botanical conservation and research